Hi students, and welcome to another episode in our C# fundamental course. In our last lecture we discussed the very basics of classes, and today we are going to continue in exactly that same topic. We are going to learn the very fundamentals of inheritance, of derived classes. Let me show you what that is. We are going to do this exercise by calculating the exercise that we did together last time. So take your geometry calculator version 2 that we created in our last lecture. For those of you who are not in my school at HTL, you can find the source code in GitHub. Please take this directory and simply duplicate it. I did that here, and I'm going to here change that to V3. So now we have the geometry calculator V3. And then open up inside of the geometry calculator V3 the subfolder solution. This is what you want to open. I opened up the sample code here in Visual Studio Code. Let me quickly remind you what we did in this exercise. We created 4 classes. Circle, as you can see here, ellipse, that was your homework, rectangle, and triangle. And each of those classes has certain data. In the case of the circle, that would be the radius, and logic. In the case of the circle, that would be the area calculated by multiplying pi with radius and radius. And the third thing is those geometrical constructs can be scaled. So for instance, if we take a circle, then we have a certain diameter or radius, and then we ask the question, what happens if we want to duplicate the area of the circle? How much will the new radius be? And that is exactly what scale does. It changes the radius accordingly based on the factor which is multiplied to the area. Okay, so this is what we did. Now let's take a look at 2 of those examples. Let's take a look at rectangle and triangle, for instance, and I will enlarge the font a little bit so you can see it better. Compare these 2 classes. On the left-hand side, we have rectangle, and on the left-hand side, we have the triangle. In both cases, we have some data. In this case, we have the width and the height. The same is true here on the right-hand side, but for the triangle, we have a base length and a height. And now comes the important part. Check out the calculated properties and methods of the classes. On the left-hand side, we have a read-only property called area, and we have a method which receives the factor by which we want to increase or decrease the area, and it returns void, and it is called scale. Now take a look on the left-hand side. We also have the area. The calculation is different, granted, but still it is called area. It's a calculated property. It's a calculated property. You can only read it. And we have a method with the same name, the same parameters, and the same return type. So these 2 classes are very, very similar. And this is exactly what inheritance is all about. Let me write that down for you. Inheritance. Okay, this is what we are going to do. We are going to build a so-called, let me write it down for you, base class. And this base class will act as the base for all the other geometric shapes that we have built. So rectangle, triangle, circle, and ellipse will inherit certain things from the base class. Let me show you how that works. I am going to create a new file here, and I will call this file shape.cs. Here we have the shape. Of course, I will start with the namespace. Here you see the namespace. You have learned about namespaces in our very first exercise this year. And then we are going to create the base class. Now, a class would be defined like that. Shape. And that is already a class, and that can already act as a base class. I will show you in a second how you can make shape the base class for triangle. But first, I need to describe another topic here. The shape here is only a so-called, let me write it down for you, abstraction. What does abstraction mean? You cannot create the shape, just like you cannot, measure a table. How large is your table that you are sitting at? You can answer this question because we are now talking about a concrete table, a so-called instance of a table. But if I just ask you, how large is a table? You would ask back, which table do you mean? And that's exactly what an abstraction is all about. Shape. Create a shape. Your answer would be, what shape? Triangle, rectangle, circle, ellipse, what do you want? So shape is just an abstract concept which acts as a basis, as a base class for all our other shapes. So what we can do is we can mark this shape with the word abstract. That means that this shape cannot be instantiated. That's the correct term here. We cannot create an instance of shape. We can only create instances of inherited classes, of so-called derived classes from shape. Now what we can do is we can go to the triangle and say the triangle is a shape. See? Now we have an inheritance. Triangle derives from shape. Congratulations! You have created your first inherited class. Now, the base class is not very useful as it is now because it's empty, and now we can think about what makes a shape in our situation. And maybe you can remember what we did before when we compared the rectangle to the triangle. We were looking for similarities. And in our case, we had first this similarity here. Both have an area property. And we have this similarity here. Both have a scale function. So what we can do is we can say each shape needs to have a public double area read-only property, and we can say that each shape must have a public void scale function which receives a double factor parameter. So now we say that our shape, as you can see it here, consists of area and scale. But we do not implement these things. This is just a contract. We say, hey, shapes, if you want to derive from me, you must know how to calculate your area and you must know how to scale yourself. So it's really just an abstraction. The implementation happens here. Now, as you can see, we have a bunch of warnings here and we have a bunch of errors here. So it isn't complete yet. Yes, that's true, because this word abstract that I described a minute ago needs also to be here in front of the property and in front of the method if the base class is only specifying that the derived classes must implement this property or this method. So with this abstract, we say, I, as a shape, have no idea how to scale. I have no idea how to implement the area property. But my derived classes, they will be able to do exactly that. Now, on the derived class, we need to inform C# that this property here, area, is the implementation of exactly that abstract property. And we do that by adding, by adding the word override. Override means I am overriding the method from the base class. And same is true here, override the scale method and welcome to the world of inheritance. Now we really have a meaningful base class. We have a meaningful base class called shape. Now let's try the same with the rectangle. Let's go to the rectangle. We specify that shape is the base class for rectangle. And can you remember what we did? Yes, we added override here and override here, and suddenly our beautiful rectangle is also a derived class from shape. Okay, let's try it with the ellipse. Make it a derived class from shape, add override, and add override. Now is a great place or a great time to pause the video, and now you try alone, without my help, to apply the changes to the circle class. Please do so. Great, you are back. So let's do it together. You must define the base class here. That means that circle is a derived class from shape. It inherits all the different properties and methods from shape. And we need to specify that area is the method that overrides the abstract base class here. And this overrides this one. Area is a property and this one is the method. And now we have a beautiful inheritance hierarchy. We have one base class shape, and we have in total 4 implementations. And you see that Visual Studio Code is also telling us that we have 4 implementations of our shape, that is circle, ellipse, rectangle, and triangle. Woohoo! Looks great. This is exactly our first step. That's exactly what we need as the first step towards becoming a professional object-oriented programmer. In order to complete our exercise today, I need to tell you a little bit about a very, very special class, the class object. Here you see it, the object class. Here you see the declaration of this object class. This object class has a superpower. It is, as you can see here, the ultimate base class of all .NET classes. It's the root of the entire type hierarchy. It has a superpower. The object class is, as it's written here, the base class for all other classes. However, you might say, hey, here I do not mention object as the base class of shape or circle or whatever. Yes, and you are perfectly right. You do not need to explicitly specify object as the base class of any class that you create in C#. That happens, Harry Potter like a little bit of fairy dust. It happens magically behind the scenes. You could, if you want, write object here, and it happens automatically. If I zoom in a little bit, you will see that Visual Studio Code shows us that this is done automatically by using a slightly darker font here. So it indicates, hey, this colon object is not really necessary. You can leave it out. It's not necessary. It happens automatically. Now, let's take a look at what this object class gives us. We can take a look at the left-hand side, and we see that this object class contains a bunch of methods. For this level in your C# career, the only method that you should care about is the toString method. Now, what is the toString method? The toString method is a method that has to return a string representation of the object. What is a string representation of the object? Now, I could tell you, print a circle on the screen. And you will probably say, a circle, I can't print the circle on the screen. I can draw it if I have the possibility to draw a circle, but I cannot print it as a string. And that's exactly the idea of toString. toString is a method that an object has to implement so that it can be printed on the screen. Let me show you what I mean. Here, I can say override, use the blank space, the space key here, and now you see that in Visual Studio Code I can simply enter here on the toString method, and here I can now define what the string representation of my circle should be. And that could, for instance, be return circle in parentheses. We could, for instance, say radius equals to radius, something like this. And that would now be our string representation. So if somebody asks a circle, hey, print yourself on the screen, it will print this text. So the circle now knows how to convert itself into a string. And that's the idea of toString. And toString is overridden here because it comes from a base class, from the base class object. Now, if you want to keep the implementation short and concise, you can use this syntax. I've shown you this syntax multiple times already. Here you can simply use the fat arrow, no return statement, no curly braces. It's a little bit shorter. If you prefer the longer syntax, that's perfectly fine. You can choose yourself. Now again, let's exercise that. Let's go to the triangle and add a toString implementation to triangle. Well, the only thing that we have to change is here from circle to triangle, and we need to display two different data items. The base, that could become the base length, and we need to specify the height and that would be the height, something like this. And with that, let me get rid of the shape here so we see it a little bit better. Now the triangle knows how to print itself on the screen. Perfect. Next exercise. Let's try the rectangle. Here we copy the implementation of the triangle, and I change triangle to rectangle, change the base to width, change this one to width, and change this one to height, and everything is fine. It's already height. So perfect. So now we have 3 implementations of toString. And just as before, for the ellipse, I ask you to pause the video and try to implement toString on your own. Try it. Welcome back. So I will show you what the solution is. We simply change the text here to ellipse. We change this one from base to longest radius, and change that one to longest radius. And here we say shortest radius, and here we say shortest radius. And with that, we have a perfect implementation of toString for our ellipse class. Woohoo! That looks really nice. Now we have overwritten 1 property and 2 methods. The property and the scale method comes from the shape. They come from the shape base class, and the toString method comes from the object base class, which is automatically the base class of every single class that you ever create in C#. You cannot prevent it. You do not need to explicitly state it. It just happens automatically. Perfect. We have implemented our classes. Now it's time to go to our app and try to use it. We can very much simplify what we have here. We can very much simplify our program. Let me show you how. Well, first, I am going to restructure the app here. Remember, in our original implementation, we asked for width and height and radius and base length and longest radius and shortest radius and things like that. Believe it or not, we don't need these global variables anymore. So we can remove them and we replace them by a shape. Shape, shape, something like this. Now you might ask yourself, okay, here we say shape. Which shape do you mean, Rainer? Let me show you how this works. We can now use local variables here, see it? But the important thing is that here in the switch case, where we ask the user, which figure do you want to have? And the user said, I want a rectangle. We simply say here, shape equals new rectangle, see? And we specify the width and the height, and we are done. This is magic. This is where the magic happens. Remember, the rectangle is a derived class from shape. And because rectangle is a shape, it is perfectly fine to assign the rectangle to the shape variable, which is of type shape. And that is what abstractions and what derived classes and inheritance is all about. We program against the abstraction, but we instantiate the concrete class. We create the rectangle in that case, but we assign it to a shape. You might ask yourself now, and what does that bring? What's the advantage here? Give me a second, you will see it in a second. Let's do the same with the circle here. Make it a local variable, and guess what? We are going to say this is a new circle, and we specify the radius, and we have the shape for the circle. Worked perfectly fine. Next, here we can specify a local variable. Height has already been declared up here, so it's perfectly fine to reuse this variable. And we say shape equals, what do you think? Correct, new triangle. And give it the base length and give it the height. And we are good with the triangle. Now again, it's up to you. Make the changes here for the ellipse. Pause the video and resume it as soon as you have done all the necessary changes. Welcome back. So I will show you what you should have done. Make these two things local variables and assign the shape to a new ellipse. and give it the longest radius and the shortest radius, and we are good. Now, at the end of this large switch statement, we have our shape, circle, rectangle, triangle, or ellipse, inside of this variable here. And this variable is a shape. Here, at the end of the switch statement, we really don't care whether it's a rectangle or a circle or a triangle or an ellipse, because it's enough that we know this is a shape. Let me show you what I mean. Down here, where we have this endlessly long code here, we can extremely simplify this code. Let me show you what I can do. I will remove all this switch stuff. I will remove this new triangle and just keep these 3 lines of code. Everything else in your program will be, whoops, deleted, as you can see. We simply delete everything else because now we can use the methods and properties of the abstraction. Let me show you what I mean. First line here. The original area of the, and here I'm simply specifying shape. What's going to happen? The shape should be printed on the screen. So at this location, C# will call the toString method. So the shape knows how to print itself on the screen. It will say the original area of the rectangle or of the circle or of the triangle. That is what will be printed on the screen. And here instead of rect, we simply say shape because all our figures, all our geometric figures are shapes. We can simply say call the area. And if the user specified that he wants to have a rectangle, C# will be smart enough to access exactly that area here because our shape is a rectangle. And if the user is smart enough, if the user specified that he wants a triangle, then this here will call this formula for calculating the area. Because at the end of the day, this is a so-called abstract method which was overwritten, so C# will always select the correct method, the correct property. Now you probably already know what I have to change here in line 44. I change rect to shape because all our shapes know how to scale themselves. Now this right line, we can greatly simplify it because this width and height stuff, that's already part of our toString method. So we simply say the new area of the shape is, and here we say again, shape. And now guess what? Our program is done. We have just deleted over a dozen of lines of code and still our application works perfectly fine. Let me demonstrate that to you. I will open up the terminal, make it a little bit larger, and I will simply say .NET run and specifically run the project geometric calculator app. This is what I want to run. C# will build everything and will probably ask me now what I want to have. I'm going to go with a circle. I specify the radius should be 2 and I want to triple the size of the circle, and you see, I will zoom in, the output is perfect. We see the original radius was 2 and the original area was 12.5. The new area of the circle is 37, which is approximately a tripling of the area. That's exactly what we wanted. And we get informed that this is now a new radius of 3.46 and so on. You can read it on the screen. That's exactly what I wanted to do. And do you see how beautifully that worked? Because we introduced this abstraction here, this base class. This is what object-oriented programming is all about. Now it's time for you to practice. I have created a homework for you. And I invite you, I ask you to do this homework as soon as possible. For those who follow in the HTL in my course, you have to do the homework until Thursday. And that is the service fee calculator. You can find it in our GitHub repository. Here you see the base URL of the GitHub repository. For those who just watched the YouTube video, I will add a link to the GitHub repository in the description of the video. And here you find it in the folder homeworks, you find this service fee calculator. In this time I created a small little hero image with Midjourney artificial intelligence just to raise the mood a little bit. What are we going to do? I ask you to implement a service fee calculator for a mechanic shop. This mechanic shop offers 3 types of jobs. It does basic repairs, regular repairs, and complex repairs. Please read the requirements carefully. To make a long story short, basic repairs done by junior mechanics, 15 euro per hour. Regular repairs, senior mechanics, 80 euro per started hour. Complex repairs, master mechanics, 500 euros if repaired within 4 hours. 800 euros if it takes longer, and you do not have to pay if the repair was not successful. So the master mechanics, they really know their stuff. They are pretty sure that they can repair nearly everything. Now, every repair job has a description. A description could, for instance, be, please repair my smartphone, or please exchange my smartphone display, or please repair my washing machine. Then every repair job has a start time and a start date, an end time and an end date that you can see here, and a flag indicating whether the repair was successful or not. So what do you have to do? In level 1, that's the basic. I demand that everybody does exactly that level. That is no discussion. You must be able to do that in order to pass our course. What do you have to do? You have to create 4 classes. You have to create a base class repair job. That will be similar to our shape class from the exercise that we did together. Then you have to create 3 derived classes: basic repair job, regular repair job, and complex repair job. That would be in analogy to our circle, to our rectangle, and to our triangle, and so on. So these classes here, they derive from shape. Now, shape in our case has some properties, and to make your life easier, I have added here the syntax with which you can add the properties to the repair job base class. Repair job must also contain an abstract method, calculate fee. So repair job says whoever is a descendant from myself needs to know how to calculate the fee for the respective job. And the derived classes have to implement the method calculate fee based on these requirements that you see up here. Okay? So this is the important thing that you have to try. I know that in this course we haven't done a lot of work with date times yet, but now we are starting to. So to make your life easier, I added a little sample code here which shows you how to turn a string that the user entered into a date time and how to calculate with date times. You can simply subtract them and then you can ask for the total hours. Okay, so in this case, 9 o'clock to 11:30, that is 1.5 hours. So the return of total hours would be 1.5. Once you created this class library, you have to create a console app which allows you to test your class library. Ask the user for the necessary data, create an instance of the appropriate class, call the calculate fee method, and print the result on the screen. This is the basic. You have to solve level 1. Now, those of you who are already pretty fast and who want to an extra challenge, I have additional levels here. Here you see there is a level 2. Most of you should be able to solve level 2. There is a level 3, which is a little bit tricky. It's a very short change, but still a little bit tricky. And then we have a level 4, which is already quite advanced. You should only try level 4 if you have prior experience or if you are really talented in coding and all these things are really very simple for you, then give it a try. Try level 4. I even added a level 5 for those of you who need an extra challenge. I will not read through the levels 2 to 5. You can do that on your own. If you are stuck while working on these requirements at home, please note that I added a sample solution, but not for all levels. I added a sample solution for level 1, level 2, level 3, and level 4. Do not copy my sample, of course. Try it on your own. Then you can compare your code with my code. If you want to tackle level 4 and level 5, you will not get a sample solution from me. If you are in my class, you can ask me. Otherwise, try to do your very best to come up with a good solution for level 4 and level 5. So that was our lecture today. Derived classes, inheritance, abstract base classes, a very important topic for object-oriented programmers and something that we will from now on use in nearly every application that we write. Enjoy working on your homework. See you in school or see you in the next lecture here on YouTube.